Hello and welcome. Today we're going to begin talking about early childhood development, and we're going to focus on the biosocial perspective. So just to get some general stuff out there, compared to an unsteady 2-year-old child, the 6-year-old is all over cartwheeling, doing all kinds of crazy things. So really what happens between age 2 and 6 is where we're going to be coming to focus on. At some point, their fine motor skills, their gross motor skills improve as their brain growth improves. And, that's the kind of thing we're going to be focusing on most since we're in a psychology class. We're going to be looking at the myelinization process, habituation, all kinds of cool concepts. But again, what's really happening between age 2 and 6? So physical differences are obvious as are changes in proportions. Their bodies are starting to grow. Their body fat trims down, it's replaced by muscle. The average body mass index is lower at age 5 and 6 than at any other time in a life. And again, just look at a 2-year-old compared to a 6-year-old and ask, what's the difference? What do you see? They've grown, their brains are growing, their language is growing, their skill levels are growing. Okay. Physical differences are obviously growing. All right. And also at this time, baby teeth are typically replaced and are naturally about age 6 to 10. So by about 10 years old, most of our baby teeth have been replaced by main teeth. Again, the number one thing for all growth, physical and, brain, even though they're the same exact thing, is nutrition. So it's very important that kids are getting the nutrition that they need. However, about half of young children who are overweight tend to become obese later on. So again, any of these issues with nutrition can last across a lifetime. Early childhood is the best time to establish good nutrition because these eating habits endure. So if you raise them eating carrots and more healthy things instead of donuts and sugar and cheeseburgers, that's the kind of habit that they'll get used to. So again, this idea of prevention includes developing the healthy habit of eating healthy foods when hungry and not overeating to avoid problems associated with things like obesity. However, many children snack on salty and sugary foods and drink soda instead of fruits and vegetables. But again, a lot of this is constructed by our cultural habits. Think about the culture you live in. What kind of food do you have accessible to you? How is that associated with eating patterns, rise of obesity? And again, you can see over here, as we've introduced high fructose corn syrup into our diets, other high fat, more processed foods, you're seeing this trend. And this kind of goes up and down a little bit, but if you compare it to the 1970s to, the last 10 years, it's at least doubled, if not almost tripled. So something to think about. Why are these rates varying? And then regarding allergies, an estimated 27% of US children have an allergy, but again, these are estimations. In countries like the United States, it's much more highly reported where we have access to healthcare facilities than in other countries, for example. Boys, however, do have higher rates of allergies they tend to find. And overall, about 6% of children have food allergies when we thinking about milk, eggs, peanuts, tree nuts, soy, wheat, fish, and shellfish. Many food allergies are outgrown. Your book does get into a discussion of whether you should try to like slowly introduce things, even if they're allergic, to get over it. But there's really no research suggesting either way, what it is. It could just be age, it could just be getting used to things, whatever it might be. But again, for early childhood, we need to recognize two facts. Food allergies complicate achieving a balanced diet, and nutrition is particularly important. Now, on to the really interesting psychology again. These kids are growing from 2 to 6, their bodies are growing, their brains are growing. What really happens? By about age 2, as we've discussed, most neurons have connected to other neurons and substantial pruning has occurred, meaning we have the beginnings of a highway system. So I put this map over here on the right because this is just the best way to kind of think about it. If you go back to Columbus 200 years ago, you didn't have all these interstate systems and then this circle that goes all the way around the city with 270. You didn't have 70 going east and west and 71 going north and south. You had a couple of farm roads. Here on 161, this is an old farm road. Broad Street coming out of Pennsylvania is an old farm road. And before that, these were all Native American roads. And a lot of these Native American roads also followed the wildlife tracks. And so, again, this plot of land has been conquered many, many times. Okay. But think about a 2-year-old kid is kind of like Columbus in the 1800s, right? You have a few roads, they're dirt roads. We haven't invented concrete, we haven't invented asphalt. Those roads are like the neural pathways, and all of these neural pathways are insulated by something called myelin, the myelin sheath, which I have right down here. The myelin is the white matter of the brain, and the gray matter of the brain is the neurons themselves. The myelin coats the axons, protecting and speeding signals between neurons. Okay? So, what happens between age 2 and 6? And you guys all should know from intro to psychology or whatever how the cell works, right? So again, the dendrites release neurotransmitters. They're absorbed by the next neuron, which then fires an action potential to stimulate the neuron to go on, basically, which then releases more. And so basically, what connects all of this is the myelin sheath. I often think about it like telephone poles. Look at the telephone poles and the electric wires and how they have a wrapping around it. The wire is the neurons, and the wrapping around it's the myelin sheath. So, what happens is this. Now imagine that as a kid grows from like 2 to 6 and then up to 25 and then throughout their lifespan, we build these interstates. Imagine the interstates are like myelin sheaths. The better and more efficient and the more of these interstates we have, the more cars the neurons can travel on this interstate. So your myelin sheath is kind of like an interstate, which is just, holding in the neuron transmissions, right? And in keeping them in place. What happens when you have multiple sclerosis, for example, is these neurons, these cars are basically flying off the road because there's a breakdown in the myelin sheath. If there's no myelin sheath here on 270 on the west side, then cars will just be flying off the interstate, for example. The myelin sheath is what keeps the cars traveling along the interstate. So what's happening between age 2 and 6 is these interstate systems, these myelin sheaths are being formed and they're connecting all of the other parts of your brain. So again, you can go from downtown Columbus and take Cleveland Avenue through this. You can go from downtown Columbus and take Interstate 71. You can take one of the older streets like High Street 23 and take that up north. You can also cut over to Ohio State and take 315 all the way north. And so what's happening is as you grow, your brain is making more and more connections to Dublin, over here to Hilliard, coming down to Grove City. And that happens through the process of myelinization. The myelinization process is your brain forming these neural pathways that are wrapped in myelin that enable all the parts of your brain to be interconnected and communicate with each other. Okay, so that's why as these kids are growing up, their brains, their neural pathways are getting more and more efficient. Okay, as they make more and more sense of reality, as their brain figures out how to use their body, for example. Okay, so remember that a 2-year-old's brain already weighs 75% of what it will weigh in adulthood. It's already gone through a good pruning process, meaning it's kind of wiped out any of the old roads that we don't use anymore, and it's made much more better efficient roads to connect the parts of the brain that it needs to connect. And then by 6, the 6-year-old brain is 90% of an adult's weight. Okay. And then the rest of it just comes with time as we develop more and more myelin and we more and more neural pathways to connect more and more parts of our brain. Okay. So myelin is not just mere insulation around the axons that make it so the chemicals don't just go flying off. The electrical signals don't, all right. It organizes the very structure of network connectivity. Again, this interstate system, this road system, it organizes our ability to like go to one part of town to another to go pick up some food, or come over here and go pick up something over at Target, or come down here into downtown and go to a cool restaurant and walk around and see a hockey game. Again, so it's this myelin system, this system of neural pathways that enables us to make sense of reality and get around the world really easy. Okay? It also regulates the timing and information flow through individual circuits because, again, the more efficient your interstate is, the more cars, the more neurons can pass through. So, as your myelin system becomes more and more efficient, the easier it is for you to do certain tasks. Like a basketball player, the more and more they throw the free throws, the more and more these interstate systems, these myelin sheaths that connect the neurons, become more and more efficient, the easier it is and the more accurate they are as they throw three free throws. So again, practice makes perfect because it's through practice that the brain connects other parts of the brain and learns and is involved in memory and skill formation and all of that. that grows as you practice. So what are kids really doing from 2 to 6? As we grow, as we interact in the social context, as we use our brains, we're practicing. You're doing that your whole life. It's kind of a way of thinking about it, right? You're just trying to figure out how to get around in this world. So you practice at your job, you practice at your relationships, you practice at your friendships. You know what I mean? And as you do this more and more, it should get more and more efficient. Okay. Now, if you look at other primates, they may have, in other ways, better brains and bodies. Like monkeys can climb trees and go faster than a human can, right? And many creatures have sensory acuteness that humans lack. Like dogs can smell things and hear things, and bats can hear things and see things at night that humans can't. Okay? These other creatures have evolved neurons devoted to those senses. We don't build neural pathways to have super awesome eyes and super awesome hearing. We really build neural pathways to engage in social and then whatever we need physical, like, be able to run, walk, plant, things like that, use our hands, find motor movements. That's what our brains are really interested in. Okay. So again, what we're really focused on is other people. We're just quite obsessed. All right. But humans also have these intellectual capacities beyond any other creature because our myelin enables people to use many parts of the brain at once. So again, you probably heard that adage that we only use a certain percent of our brain. That's not true at all. It's just that when you're doing some tasks, these parts of your brain might light up. Do a different task and some other parts of your brain might light up. But again, you're using all the lobes of your brain, all the parts of your brain are involved in these processes. If you have an emotion, it's happening in the limbic system and may start in your amygdala and then it sends information to your prefrontal cortex, which is out here, and then you reflect upon your emotion. If you experience a fearful situation, your amygdala lights up, sends signals to your prefrontal cortex, you reflect upon that. We'll talk about that in a second. But again, it's this myelinization that enables us to do these higher level thinkings. We can connect all these parts of our brain to make sense of our reality. Okay. So also, the myelinization process is what they say is especially evident in the major link between the left and right hemispheres. That corpus callosum that runs, between the middle of our brain, that's just a whole bunch of myelin interconnecting a bunch of neurons so that they can cross over and talk, the left brain and the right brain. The left brain and the right brain need to be able to talk to each other. So the idea that we have a left brain and a right brain is this idea called lateralization, okay? Literally sidedness. This idea that you have a left brain and a right brain does hold up because the brain is split into two parts, right? The entire human body is lateralized, not only in right or left-handedness, but also in feet, eyes, ears, and the brain. Okay, so your right side of your brain connects, controls the left side of your body, and your left side of your brain controls the right side of your body. Okay, but again, this main connection between the hemispheres is a band between them called the corpus callosum, where the myelinization of millions of axons link the left and right part of the brain. Okay, so again, this middle part of your brain is just a bunch of neural pathways, a bunch of highways coated in myelin that enables these neurons to, rapidly talk with each other. Okay, and so I put in this box from your book because it really breaks it, down into some of this interesting neuroscience, and it says, you have these two parts of your brain, each one of which is called a hemisphere. The hemisphere, the left and right side, are connected in the corpus callosum, which is, again, a bunch of nerve fibers wrapped in myelin. Okay. So your brain is always growing through childhood and adolescence all the way through adulthood. But again, it's these early childhood myelinization, this early growth of the corpus callosum that really dictates overall intelligence and things across the lifespan. How good are you going to be? Again, skill training to young kids, it turns out it's just really important. So, young children being able to coordinate their hemispheres and hence the two sides of their brain, once they start to figure it out, that's when they learn to hop, skip, and gallop. And so by about 5, 6 years old, these kids are doing incredible things that they couldn't do at 2 because the myelinization, the map of your brain, the interconnectivity of all your neurons and the parts of your brain to be able to talk to each other hasn't really grown as much. Okay. So again, really cool stuff, definitely worth looking into. Now, when it comes to left-handedness, I watched a great lecture on left-handedness of the brain, and it asked why is left-handedness still part of our evolution? But again, 90% of people tend to be right-handed, and 10% of people tend to be left-handed. So how did a minority in that DNA evolve over a million years? But again, something about left-handed must give you an advantage. Otherwise, that selective, part of left-handedness would have been wiped out of our DNA. And usually I think about it as boxing. If you're boxing someone, their liver is on the right side. But if you're a left-handed boxer who can really get into that liver, that's how you knock out a boxer just instantly. You don't have to go for his face or his chest. If you can get your left hand in there and take out their liver. So again, what evolutionary advantage does left-handed have, which enabled that to be reproduced from generation to generation, and it continues to be in our DNA. Now, some interesting things about left-handed that your book talks about is that left-handed people tend to have thicker, better myelinated corpus callosums, these middle part of your brain. Why? Because left-handed people live in a right-handed world. So not only are they, dominantly left-handed and trying to do that, but whenever they can't really use their left-handed because they exist in a right-handed world because of their culture, then, they have to culturally switch over and use their right hand. And so it says lefties often need to be able to switch between the two sides of their body because they live in a right-handed dominated culture that doesn't always enable left-handedness, right? So they use their dominant left hand for tasks that either hand could do, like brushing their teeth, but they use their right hand when cultural norms require it, like shaking hands. Because a lefty would naturally want to shake with their left, right? But culture dictates shake with your right. Your left-handedness is associated with genetics. It's also associated with learning. Your book talks about in previous centuries, left-handedness was only like 2 to 4% of the population. But as we have stopped socially controlling left-handedness and enabled a left-handedness to come out as a society, then you've seen the rates grow to about 10%. Okay? And it did put in here that the brains of left-handed people may give them an advantage in professions involving creativity and split-second emotional responses to logical dilemmas because they're better at using both sides of their brain, the logical left and the emotional right, right? Yeah. So, maturation of the prefrontal cortex. The entire frontal lobe develops for many years after early childhood. Again, the most important years you're always going to hear are those early years, but again, it does go across the lifespan. Dendrite density and myelinization are still increasing and emerging in adulthood. Anytime you learn a new skill, if you start playing a new instrument, the myelinization, the neural pathways in your brain are going to change. Your brain is constantly changing, constantly evolving. Just look at a city. You have old neighborhoods that are constantly being ripped out. Then we put in some new buildings, and now it looks like a new neighborhood. Okay? So that happens throughout the lifespan, but definitely early in life is when you instill, the learning process, stimulating kids, enable them to make associations, and then their brains can grow. All right? So your book talks about in stage 6 of Erickson's sensory motor development, toddlers begin to think before they act impulsively. Again, at what point do people start to think before they start to act? So young kids, they generally just feel and express, but then by about age 6, they start to become a little bit more socially conscious. They start to be more aware of the situation. They can reflect upon what's happening better, and you start to see that generally go down. Okay. So, neurological control advances that occur significantly in early childhood. Sleep becomes more regular, emotions become more nuanced and responsive, temper tantrums subside, uncontrollable laughter and tears are less common. Your book gives the example of Simon Says to give an example of how the brain matures over time. So in Simon Says, players are supposed to follow the leader only when orders are preceded by the words Simon says. Thus, if leaders touch their nose and say Simon says touch their nose, players are supposed to touch their nose. But when leaders touch their nose and say touch your nose without saying Simon says, again, the older kids know the rules, but the youngest kids, They haven't, figured out how to think about the fact that they didn't say Simon Says. They only saw the adult touch their nose. And so the younger kids tend to touch their nose more and fail at this, suggesting that that prefrontal cortex, your executive function, hasn't really learned. The kids are still going on impulse, what they see. Your book uses another example, which I was talking about earlier, and that's the experience of sudden fear. See, kids will experience terror, sudden fear, because their amygdala isn't fully connected to their prefrontal cortex. They're feeling a bunch of stuff, but the neurons that are supposed to go from their amygdala and their limbic system to their prefrontal cortex, where they can reflect on the fear and ask, is this really something I should be scared of? That myelinization process, that connectivity between the amygdala and the prefrontal cortex hasn't really occurred yet. It hasn't grown enough. So little kids will experience this overwhelming fear because the amygdala hasn't, connected to the prefrontal cortex and they're not really talking yet. Okay. All right, cool. So, advancing gross motor skills, brain maturation, and myelinization contribute directly to motor skills as children gradually are able to move more with speed, agility, and grace. Gross motor skills improve markedly during early childhood. When playing, many 2-year-olds fall down because they haven't figured out how to use their legs yet. By the time they're 5 or 6, they're doing crazy gymnastics, they're playing softball, they're doing all kinds of cool things. Okay. Motor skills are typically mastered more quickly with practice and age rather than social skills. Again, it says in your book a 5 or 6 year old might be really great at playing soccer, but are they great at being a team player? They have that social awareness? Do they have the theory of mind where they can put themselves in another person's shoes? Are 5 and 6 year olds still obsessively self-centered? Aren't we all? But yeah, they're a little bit more so because they haven't had the ability to be able to step outside the box yet, put themselves in somebody else's shoes, see themselves from the outside. Play is absolutely crucial for development. Play enables kids to go mimic, imitate, try on things, interact with other people their own ages. It teaches them social skills, motor skills, because they're out there playing, they're playing games, they're playing with objects, they're communicating with other people. It helps them learn language. They learn to run, climb, leap, jump. Again, and it also says that it's important for kids to go play outside. Again, are we humans? Are we meant to be locked up on a couch all day long playing video games? As part of being human and interacting in the environment, touching a tree, touching grass, absorbing some of that bacteria that you get when you're outside. All right, cool. Fine motor skills. So, fine motor skills also improve in early childhood. 2-year-olds try to mash a puzzle piece into a space, not only because their spatial visualization needs haven't developed, but also because their fingers are not yet adept at rotation. So, if you ever look at kids' puzzles, why do they have a little bit of handle? It's hard for them to fit super intricate puzzle pieces into an intricate spot. They haven't, their visual skills aren't lined up yet, their hand skills aren't really lined up yet. We need something that's a little bit easier. But then by about age 6, you give a 6-year-old a toddler's puzzle that has 12 pieces on it and they'll put it together in like 2 seconds. You know what I mean? So what has really changed? Again, their ability to use their hands, their ability to use their eyes, their ability to reflect and think, where should this puzzle piece go? These are things that grow over time. Sewing, knitting, drawing, buttoning, these and fine motor skills gradually develop over time. And again, children who practice the motor skills, this helps their cognition because it's enabling their brain to grow, a better myelin system to connect a bunch of neurons to other neurons so that you can think and move faster. Okay. But again, think about little kids. Can they tie their shoes yet? No, they need Velcro. They need slip-on shoes because it's hard for them to do the fine motor skills, learning how to do the bunny, twisting the knot around, tying it, double knot. That usually comes when? It's about kindergarten, that a kid learns to really tie their shoes, 6 years old, somewhere around there. All right. Stress in the brain, we're going to get into, a little tougher stuff just to wrap this up. Remember, kids growing up in a positive environment where they're highly stimulated, where they have chances to learn, chances to interact in the environment with multiple groups of people, multiple ethnicities, genders. This is what grows your brain. Okay. However, when kids, are experiencing trauma or interruptions in their daily life, that can affect their brain. Kids growing up in poverty who aren't challenged as well in school, are they getting as much physical brain growth? Is the maturation, the myelinization process, the maturation, myelinization, myelin process, whatever the verb would be for all of these words, again, building of that interstate systems that takes good schools. It's hard to accept, but whenever you're teaching things like intelligence, again, how do you make a rocket scientist? We've talked about this in this class, but you have to push that kid, challenge that kid, force them to really learn and, figure out stuff, make them go climb trees, make them go hit baseballs and play with dolls and learn about how to talk about their feelings and their emotions. If they don't do this, then those parts of their brains don't grow. So, yes, you can look at things like poverty and how that might affect kids, but you can also look at how increased stress because of, sleeping interrupted, lack of food, issues at home, whatever it might be. There is a correlation between stress, and future neurological and cognitive development. Direct repeated maltreatment without protection is worse than a single assault. Also, so again, chronic, traumatic, chronic poverty, chronic malnutrition, abuse. These can have permanent effects on actual brain growth, not just emotional well-being, but physical growth also. Okay. It says that, it can cause a shrinkage in various parts of the brain. It can decrease the white matter. Again, these myelin highways have reduced connections between parts of the brain. All right. And then there's injury. There's three levels of prevention that apply to every health and safety issue. Your book breaks it down into primary prevention, considers the overall conditions that affect the likelihood of harm. Laws and customs reduce injury for people of every age, for example. Secondary prevention is more targeted, averting harm in high-risk situations for vulnerable individuals. And then there's tertiary prevention, which begins after an injury has occurred, limiting the overall damage. But again, think about all the things that kids are exposed to in the environment. Your book talks about poisoning, accidents, gun violence. Again, it's car accidents and guns that kill kids more than cancer. It used to be cancer, but we've reduce the cancer rates. If you look in your book, there's a chart by about half for kids, but the, issues from other people harming kids and then accidents and guns, that is going up. Okay. So here's your overall charts of maltreatment. Yes, we've seen a reduction in maltreatment. It could be because socioeconomic levels have improved, education levels have improved. Parents maybe are more informed. Maybe they have more access to help and support than they had back in the day. It could be that our cultural attitudes have changed and we don't hit our kids like we used to. But again, if you look at substantiated cases of maltreatment in the United States, even in the last 20 years, you will see a decline. And so again, in psychology and sociology, we would have to figure out why is there a decline? Is it something in the parent's brain, the where they're thinking? Is it the social context that's somehow influencing this just reduction? But as you can see, the highest rates are neglect, followed by physical abuse, sexual abuse. Okay. But childhood disease deaths have decreased markedly with immunization, new treatments, and better nutrition. And as you have just read, accidental deaths are decreasing as public health scientists discover and advocate prevention. In 2021, more US 1 to 4 year olds, though, were murdered than died of the leading disease of cancer. Child maltreatment refers to all intentional harm to or avoidable endangerment of anyone under age 18. Thus, maltreatment includes child abuse, deliberate action that harms physical, emotional, or sexual well-being, and child neglect, failure to meet essential needs. But again, if you want to help a healthy child grow, get them some food, give them a hug, give them a friend to play with, keep them warm, and that kid will probably turned out okay. All right. Hope you guys enjoyed this one. Thank you so much.